Am I audible now? Please check. Please check. Yes. Okay, Sham. Very good. Very good. Very good. Here also, am I visible, audible? Yes. Okay. So very good morning to everyone. Good morning. Good morning. Good morning, everyone. Okay. So what we were covering in the previous class, I think we were discussing about vernier caliper. In the previous class, we have discussed about vernier caliper. Vernier caliper is a type of measuring instrument. It's a type of measuring instrument. Okay, we can measure length with precision, very good precision compared to our normal scale. A normal scale has a precision of 1 mm only, and vernier caliper may have a precision of 0.1 mm. A standard vernier caliper that we always used in our laboratories has a precision of 0.1 mm, and there may be better precision available because of the some design factors. Okay, so it can give you readings with better precision than your normal scale. And how vernier caliper were working? It was having two scales, main scale and vernier scale. Okay, and there was some difference in the marking schemes in the main scale and vernier scale. In main scale, the marks are 1 mm, in vernier scale, marks are at 0.9 mm. That's why we were getting more precision. Okay, now today we are going to start screw gauge. Today we are going to start screw gauge, right? Screw gauge. Screw gauge. Okay, why the name is gauge and screw? It works on the concept of screw, and it was used to measure the wire gauge. That's why the name was screw gauge. Very good morning everyone. Navid. Okay, so screw gauge was used to measure the gauge of wire. Gauge, what do we mean by gauge? By gauge of wire, if a wire is of smaller gauge, then the diameter of the wire was large. To measure the diameter of wire, we were using the screw gauge. That's why the name was screw gauge, and because it uses the concept of screw, that's why the name was screw gauge. Okay, what is the concept of screw? What is the concept of screw involved here? You must have seen a screw or the bolt. It has some threads on it. This is our bolt or screw. It has threads. We must have seen this bolt in our life. Somewhere or other we may have seen this bolt. Okay, a bolt has threads. A bolt has threads along it. The distance between the two grooves or the two troughs in this bolt is called pitch. The distance between the two grooves or the two troughs in this bolt is called pitch. When we thread the bolt in a nut, suppose there is a nut also here. I am drawing a nut here. Suppose there is a nut also here. There is a nut here. Okay. So if you thread your bolt through the nut, in one complete rotation, it travels some distance forward or backward. In a complete rotation, it travels some distance forward or backward. If you try to rotate like this, it will go down, go forward. If you try to rotate like this, it goes back. So in one complete rotation, the distance traveled by the bolt is nothing but pitch. Pitch is the distance traveled by screw or bolt in one complete rotation. That is pitch. Pitch is very important because this concept of pitch only screw gauge is working. So we need to understand what is a pitch. So if there are n rotations, suppose we are not rotating bolt by one time, we are rotating it by n time. In n rotation, if distance is x, then pitch will be x by n. Pitch will be x by n. In one rotation, the distance is pitch. In n rotation, the distance in n rotation is given. We can divide that distance by number of rotation. That will give you pitch. So pitch is distance moved divided by number of rotation. Number of rotation. Now, do we understand what is the concept of pitch? whenever you rotate a bolt in a nut, it travels some distance forward or backward. That distance is called pitch. In one complete rotation, the distance traveled is called pitch. Okay, tell me, is this concept clear or not, everyone? Tell me, is this concept clear? Yes. Okay, very good. All are saying this concept is clear. Very good. So we have started with the concept of pitch. What we are learning here? We are learning the idea of screw gauge. We are learning the concept of screw gauge. So first we have covered the idea of pitch. Why this is important? This is important to understand the least count of screw gauge. The least count of screw gauge. The least count of screw gauge. Least count of screw gauge. In one complete rotation, the screw travels by distance equal to pitch. In one complete rotation, it travels by distance equal to pitch. So in one complete rotation, there is a head of the bolt. It will rotate by 360 degree. In one complete rotation, the head of the bolt will rotate by 360 degree. Okay. So if I attach a cap or cylinder with your bolt, I am attaching a cylinder with your bolt. This is your bolt. It has threads. This is your bolt. It has thread. I am attaching a cylinder with it. So in one complete 360 degree rotation, it is traveling by a distance of pitch. It is traveling by a distance of pitch. So to measure 360 degree rotation, let us put marks here. Let us put marks here. Suppose I am putting a mark 0 here. I am putting a mark 0 here. So in a 360 degree rotation, this mark will rotate and again come back to the initial situation. I am putting a mark here in a 360 degree rotation. In a 360 degree rotation, this mark will rotate and again come back to initial position. I can understand there is a 360 degree rotation if this marks rotate and again come back to initial position. Is this clear? In 360 degree rotation, the mark will again come back to initial position. Okay, so I am putting a mark 0 here. If I put some more marks here, let's say 1, 2, 3, some more marks are put in here. I am creating n marks. So n minus 1, n minus 2, n minus 3. These are the marks. From 0 to n, 0 to n minus 1, there are total n divisions. I am making n divisions or n marks. N marks on head. I am creating n marks here. So in total 360 degree rotation, the 0 will again come back to the initial situation. In that, the screw travels by distance of pitch. In 360 degree rotation, the screw travels by distance pitch. So in n divisions, there are n divisions here. So in the rotation by n division, the distance traveled is pitch. In n division, in 360 degree, I am creating n divisions here. N divisions or n marks on head in 360 degree or one rotation. In one rotation, the distance traveled is pitch. So it means n divisions, distance is pitch. Then what will be the distance in one division? Distance in one division. In one division, distance will be pitch by n. Pitch by n. If I rotate the head of the bolt such that only one division is moving, Suppose instead of 0, I am rotating this, I am opening this, first line is coming in alignment here. Then the distance traveled by the bolt should be pitch by n. That is nothing but the least count of screw gauge. Least count of screw gauge is pitch by n. Number of division. What is n? Number of division on head. Pitch, we already know the distance traveled in one rotation, and n is number of divisions on head. Okay. So after knowing the concept of least count, now we can understand the concept of screw gauge or the working of screw gauge. So I am drawing here our bolt. This is our bolt which has threads with it. This is our bolt which has threads with it. This bolt is threaded into a long cylinder. This bolt is threaded into a long cylinder. This is a hollow cylinder. There is a handle which connects this metal piece with this hollow cylinder, with grooves. This bolt is coming behind, and this is the head of the bolt. With the head of the bolt, we are attaching a hollow cap. With the head of the bolt, we are attaching a hollow cap here. We are attaching a hollow cap here. See, this is a hollow cap. This is attached with our bolt. This is attached with our bolt. We are attaching a cap here. I am showing this cap in the green color. I am showing this cap in the green color. Okay, because of this cap, nothing inside will be visible. Because of the cap, whatever is inside, it will not be visible. Because of the cap, whatever is inside, it will not be visible. So let's make it dotted. Actually, it is not visible. Because of the cap, this bolt and everything is not visible. Okay, because of the cap, everything inside is not visible. That's why I am making everything inside dotted. Okay, now what we are doing here, we are creating a engraved line on the bolt. I am creating an engraved line on the bolt. When this engraved line on the nut, on this bolt, when the bolt is touching this metal piece is called stud. This metal piece is called stud. When the bolt is completely tightened so that it is touching the stud, when the bolt is touching the stud, in that situation, this nut has a zero engraved here, and the cap has a zero line engraved here. They are in alignment. And there are some more marks on this cap. There are total n marks or n divisions on the cap. So starting from 0, 1, 2, 3, and if you rotate, you will get n minus 1, n minus 2, n divisions here. N divisions. This is the situation of ideal screw gauge. This is the diagram of ideal screw gauge. In ideal screw gauge, there is a bolt. This is bolt with thread. When we are tightening the bolt completely, the bolt is touching the stud here. There is no gap here. In that situation, the zero of this line is engraved on the nut. This line is fixed. So this line is called main scale or linear scale or pitch scale or fixed scale. These are the names of this line. So we have a linear scale here. This linear scale contains some marking. Only one zero is available here, visible here, because other markings are behind this cap. If you extend this linear scale, you may see this linear scale and other marking, they are behind the cap. And on the cap scale, there are also some marking. Total n divisions are there on the cap scale. The situation when the bolt is touching the stud, the zero of the cap is in alignment with the linear scale. When the cap is completely tight, the bolt is touching the stud. In that situation, zero of the cap is in alignment with the linear scale. Okay. So if I rotate the cap like this, the bolt will move back. If I rotate the cap like this, the bolt will open and cap and bolt both will move back. If I rotate the cap, bolt and cap both will rotate and the cap will move back. So let me draw that situation. I am rotating the cap so that bolt is moving back. This is our cap, this is our bolt. I am rotating the cap, so now bolt is moved a little bit back. This is our bolt. It is moved back by some distance. Let me show you the cap here also. This is the cap of the screw gauge. This is the diagram observed when you are rotating the bolt by some amount. Okay, suppose we are rotating the bolt by exactly 360 degree. We are rotating the bolt by exactly 360 degree. In that situation, zero of the linear scale will be properly visible, and by exact 360 degree rotation, first line on the linear scale will be visible. First line on the linear scale will be visible, and the zero of the cap will move, rotate, and will again come back to alignment with initial line. This will be the situation. This will be n-1. This will be first rotation, first division. So when the bolt is touching the cap, when the bolt is touching the stud, when the bolt is touching the stud, the zero of the cap is in alignment with the linear scale. If I rotate by 360 degree rotation, the bolt will move back by some distance, and now first line on the linear scale will be visible. In a complete 360 degree rotation, the zero will go, rotate, and again come back to alignment with linear line. In this situation, the distance traveled by bolt should be equal to pitch. This gap here, it should be equal to pitch, because in one complete rotation, the bolt travels a distance of pitch. So we can measure the distance is equal to pitch here if we are seeing the mark 1 on the linear scale. If I am seeing the mark 2 on the linear scale, the distance here will be 2 pitch. If I am seeing the third mark on the linear scale, the distance here will be 3 pitch. That's why this is called linear scale or pitch scale. It shows you how many complete rotations are done. How many complete rotations are done. So if I show the diagram with total 3 rotations, if I show you the diagram after 3 rotation, suppose this is diagram after 3 rotations, then 1, 2 and third line will be visible on the cap, on the linear scale, and this should be the arrangement, and the zero of the cap should be in alignment with the linear scale. This is diagram after 3 rotation. After 3 rotation, the gap here will be 3 into pitch. This is after 3 complete rotation. So our linear scale has markings. Linear scale has marking. When you rotate the cap by 1 complete rotation, the zero of the cap will rotate by 360 degree. It will again come back to alignment of the linear scale or the blue color scale. And on this scale, first line will be visible. In 3 rotations, 3 pitch distance should be here, and third line on the linear scale will be visible, and the zero of the cap will be in alignment with the linear scale. Is this idea visible? Is this idea understood? The distance moved by the screw or bolt in 1 complete rotation is equal to pitch. So after number of complete rotation, some number of marks will be visible on the linear scale. Okay, if 3 lines on linear scale is visible, it means 3 complete rotations are done. In 3 complete rotations, the distance here will be 3 pitch. In 1 complete rotation, the distance here will be 1 pitch, and the first line on the linear scale is visible. So what are the marking visible on the linear scale? That tells me how many complete rotations are done. How many complete rotations are done? Please check, is this clear? Many of you are saying me correct. Okay, very good. So let us move forward. And suppose after rotating the bolt by 2 complete rotation, I am rotating it by some more angle. After rotating the bolt or cap by 3 complete rotation, I am rotating it by some more angle. So after 2 complete rotation, the second line on linear scale will be properly visible, and because of the some extra rotation, now zero of the cap won't be in alignment with the linear scale, because you are rotating some extra rotation now. So zero of the linear scale, zero of the cap scale should not be in alignment here. Let's say some other mark is in alignment here. Let's say 36th line or 36th mark is in alignment with the linear scale. For example, I am taking 36th mark is in alignment with linear scale. Suppose this is the situation. This is our screw gauge, this is our bolt, this is our stud. Then what would be the distance here? What would be the distance here? Let's say this distance is D. What would be the distance here? I am seeing two complete marks on the cap scale. On the linear scale or the pitch scale. I am seeing two complete marks on the pitch scale. Pitch scale. It means the distance is at least equal to 2 pitch. Total 2 rotations are done. This scale gives me the number of rotation. So 1 and 2, two lines are seen on the linear scale. So 2 rotations are done. So this distance is at least equal to 2 pitch. At least minimum equal to 2 pitch. But see, the 0 of the cap is not in alignment with the linear scale. 0 of the cap. In exactly 2 rotation, if there is exact 2 rotation, 0 of the cap will be in alignment with the linear scale. In exactly 1 rotation, 0 is in alignment with linear scale. In exactly 3 rotation, 0 is in alignment. There is some extra rotation. How many divisions are passing here? 36 divisions are passing. 36 divisions are passing. In each division on cap, in each division of cap, the movement here is pitch by n. There are total n divisions of cap. In each division, the movement is pitch by n or least count. Pitch by n was least count. We have covered no least count. Least count is pitch by n. Pitch by n. It is the distance traveled in one division on the cap scale. When I rotate the cap so that after 0 first line comes in alignment here, for first line the distance here is least count. For second line the distance here is 2 least count. For third line the distance here is 3 least count. For fourth line distance here is 4 least count. So it means in this diagram, now this gap D is second line on linear scale is visible. So 2 into pitch plus 36th mark on the 1 year, 36th mark on the caliper cap scale is in alignment with linear scale. So at least 36 into least count distance is also traveled. If first line of cap scale is visible, 1 into least count distance is also there. In 36 mark, 36 into least count distance is also there. So the diameter of the ball is 2 into pitch plus 36 into least count. Is this clear? This mark 2 is called main scale reading. Main scale reading. This mark 2 into pitch is called main scale reading. Into pitch, this is called main scale reading. What is the distance traveled by main scale? That is called main scale reading. Plus this 36, this is called circular scale reading. This 36 is called circular scale reading. Circular scale reading. This is circular scale reading into least count. Main scale reading plus circular scale reading into least count. This is the formula to measure the length by screw gauge. Measure the diameter of anything, measure the gap between bolt and stud in screw gauge. It is given by main scale reading plus circular scale reading into least count. Main scale reading is the distance given by the main scale. It is the distance shown by the main scale. It is the number of division on main scale into pitch. 2 marks on the main scale is visible. So usually in main scale, every mark represent 1 pitch. Every mark represent 1 pitch. 2 marks are visible, so 2 pitch. And 36th line is called circular scale reading. The mark on the circular or cap scale, which is in alignment with linear scale, that is called circular scale reading. So circular scale reading into least count, this is the extra distance. This is the total distance measured by the screw gauge. Is this formula clear? Formula for measurement of distance by screw gauge. Please check. Formula to measure distance by screw gauge. Very good. Thank you. So the distance traveled by the distance measured by screw gauge, is obtained with help of how many marks on the linear scale is visible. The marks 2 in this situation, 2 marks on the linear scale is visible. So 2 into pitch, this is called MSR, main scale reading, plus circular scale reading into least count. This is the total reading of screw gauge. The total reading of screw gauge. Okay. So let us do one practice question. Let us take one practice question. Okay. read the reading of screw gauge. Find me the reading of screw gauge. I am showing you some detail here. I am showing you some measurement here. Give me the reading of screw gauge. If pitch equal to 1 mm and least count of screw gauge is 0.01 mm. Least count of screw gauge is given and pitch is also given. Give me the reading of screw gauge. Give me the reading of screw gauge. Everything is given to you. Give me the reading of screw gauge. Give me the reading of screw gauge. In this example question, I want you to tell me the reading of screw gauge. Give me the reading of screw gauge. Pitch is given and least count is also given. Sham, your answer should also contain units. Without units, your answer is incomplete. Yes, now it's correct. Very good. Bhagdevi, very good. Vijay, very good. Very good, Anand. I want you to tell me the reading of the screw gauge. The reading of the screw gauge. How many divisions on the linear scale? This must be linear scale. What else it could be? So 0, 1, 2, 3, 4. Fourth line of linear scale is visible. Every line normally means a pitch. Every line normally means a pitch. So after 4 division, there is 29th division on the cap scale. So the MSR main scale reading is 4 into pitch, that is 4 mm. CSR circular scale reading is 29. So diameter measured will be, diameter whatever it is measuring, distance measured will be 4 mm plus this 29 into least count 0.01. 29 into least count. So answer should be 4.29 mm. This is the reading of screw gauge. How to measure the reading of screw gauge? By observing the linear scale reading. And sir, when you are doing problems on this chapter, we want to consider round off also. No, here round off is not required because all things are measurement here, na? All things are measurement here. When we are measuring something, we will not round off this. Okay, but if you are using this measurement to do something, if you are using this to do something, then we will use round off. Suppose you are adding 2 readings or subtracting 2 readings, then round off is required. Okay. Okay. So let us do one more question. In a screw gauge, bolt travels by 1 mm in 2 rotations. In 2 rotations. Bolt travels by 1 mm in 2 rotations. And there are 50 divisions on cap. There are 50 divisions on cap. There are 50 divisions on cap. Find the diameter of steel ball if in measurement third line of linear scale is visible and let's say 21st line 21st line of head scale is matching with pitch scale. So I am trying to use different words here so that all words can be used. In a screw gauge, bolt travels by 1 mm in 2 rotations and there are 50 divisions on cap. Find the diameter of steel ball if in measurement third line of linear scale is visible and 21st line of head scale is matching with pitch scale. So this question do not contain any diagram. By language we have to understand what is given. Solve. In a screw gauge, bolt travels by 1 mm in 2 rotations and there are 50 divisions on the cap. Find the diameter of steel ball if in measurement third line of linear scale is visible and 21st line of head scale is matching with the pitch scale. Sham, answer is incorrect. Please correct it, check it. This is incorrect. Aditya, we will check. Aditya, this is incorrect. You are forgetting one important line here. This is incorrect. First find pitch, then least count and use that to find the thing which is required, whatever is required. First find the pitch. In a screw gauge, bolt travels by 1 mm in 2 rotation. In 2 rotation it is traveling by 1 mm. In 2 rotation it is traveling by 1 mm. So try to understand the pitch. Pitch is distance travel in 1 rotation. In 2 mm it is rotating by 1 mm. So 1 mm is distance travel in 2 rotations. So in 1 rotation it will travel a distance of 0.5 mm. That is pitch. 0.5 mm. Then least count. Least count is pitch by number of divisions on the cap scale. So it will be 0.01 mm. 0.01 mm. This is pitch. This is pitch. Now, all things is given in the question. Diameter of steel ball is to be determined. What is the reading on main scale? Third line is visible. So 3 into pitch. This will be MSR. Main scale reading is 3 into pitch. Usually main scale reads pitch. So 3 into pitch, it should be the reading of main scale. Plus 21st line is matching. So circular scale reading is 21st into least count. This will be your answer. Solve this. Pitch is 0.5. Substitute that. 3 into 0.5 plus 21 into least count 0.01. 3 into 0.5 1.5 plus 0.21. Hence correct answer will be 1.71 mm. Answer. Very good, Pramoda. Very good. Is this clear now? 1.71 mm. Aditya, very good. 1.71 mm. There was a small variation in this question. Pitch is 0.5 mm. So every mark on the linear scale reads 0.5 mm. 3 marks on the linear scale will read 3 into 0.5 mm. This was a small variation in this question. Okay. But we will always try to read the question properly. Sometimes they can give you different things. Okay. They may tell you that linear scale is not reading pitch. Linear scale is reading something else. So in those situations, we will try to understand everything by question. Okay. Okay. So we have covered the concept of screw gauge and we have covered the how to measure the reading by screw gauge. All ideas of screw gauge we have covered. Only zero error now remains. So let us understand zero error in screw gauge. Let us understand zero error in screw gauge. Zero error in screw gauge. We have already covered zero error in vernier caliper. We know how to measure the correct reading. To measure the correct reading, we will subtract the observed reading and zero error, and we'll put a zero error with sign. Okay, whatever is zero error, we will put that with sign in observed reading. Observed reading minus zero error, this will give you correct reading. And zero error we should substitute with sign. Okay, what is zero error in screw gauge? So let us go back to the initial diagram, the ideal diagram of screw gauge. This is the ideal screw gauge. When the bolt is touching the stud, in this situation there is no gap between the bolt and the stud. When there is no gap between bolt and the stud, in that situation the zero of the linear scale is just on the head scale. You can see here zero is just in the alignment of head scale, and the zero of the head scale or the cap scale is just in the alignment of linear scale. Zero of the cap scale is just in the alignment of linear scale. So reading of cap scale here is 0, reading of linear scale is also 0. This should be the situation of ideal screw gauge or zero error free screw gauge. In this diagram, there is no zero error. This is the situation of no zero error. But suppose this is not the situation. Something else is given, or something else is observed, that there is zero error. When there is no gap between bolt and stud, they are touching. In the situation when they are touching, we are tightening the bolt too much. So that now zero of cap is shifted up. We are tightening the bolt too much so that zero of the cap is shifted up. Let me draw. I am drawing the cap with the white color. I'm not changing the colors too much. So this is my cap. This is my linear scale. I am tightening the bolt too much so that zero, this is suppose n-1 line, this is suppose n-2 and n-3 line. n-3 line now is in alignment with the linear scale. You are tightening the bolt too much so that zero of the linear scale is not visible now. This is the situation of negative zero error. Zero is up. This is negative zero error. In case of negative zero error, you are tightening the cap too much so that now linear scale 0 is behind the cap. This is the situation of negative zero error. What is the amount of zero error? How to find the amount of zero error? See how many divisions are passing here. 1, 2, 3. You can see how many divisions are passing here. So amount of zero error is negative number of divisions crossing, into least count. In every division on the cap scale, the moment of bolt by least count. So in 3 divisions, the moment should be of 3 least count. That's why the zero error is negative. If you open the bolt, when you open it a little bit, 0 will come here. So at least 3 into least count. This distance is traveled by bolt initially. When the reading is 0, the gap there will be 3 into least count. There is a negative zero error. This is the case of negative zero error. And in case of positive zero error, when the bolt is touching the stud, suppose in that situation, zero of the cap is not coming in alignment with the zero of the linear scale or main scale. Suppose second line here is in alignment with the linear scale. 0 is down. This is the case of positive zero error. 0 is down. And what is the amount of zero error? Again, the amount of zero error is very easy to find. It is positive. 2 divisions are crossing. So 2 into least count. Number of division crossing into least count. Very simple. Why there is a positive zero error? Here instrument is already reading something. Instrument's reading is positive here, that's why positive zero error. Here instrument's reading is negative, that's why negative zero error. And these 2 diagrams are drawn when the bolt is touching the stud. When there is no gap between bolt and the stud, and in that situation, suppose these readings are observed, then there is zero error. Can you see this properly? This is how we will obtain the amount of zero error, and we will always subtract the zero error from the observed reading to get the correct reading. will be equal to observed reading minus zero error. Okay, we'll put zero error with sign. Zero error positive, put with positive sign. Zero error negative, put with negative sign. Okay. Is everything visible and clear? Do we now understand the concept of zero error in screw gauge? How to measure the amount of zero error? We'll see the number of division crossing, number of division into least count. That is the amount of zero error. Okay. And how to know the positive or negative zero error? Zero up, negative zero error. Zero down, positive zero error. Let us solve one question on this. Okay, I think you have noted all this, so I will give you a question on this. In a screw gauge, least count is 0.05 mm, 0.05 mm, and pitch is 2 mm. Pitch is 2 mm. 0.05 mm is least count and pitch is 2 mm. Okay. Initially, when no gap between bolt and stud, the reading is given, and also the reading for diameter of a steel ball. Find correct diameter of steel ball. Give me the correct diameter of steel ball. I am giving you two diagrams here. One diagram is showing you initial condition in which bolt is touching the stud. That situation is given here when the bolt is touching the stud. This is the diagram when bolt is touching the stud. This is the situation when the bolt is touching the stud. Okay, and when we are measuring diameter of a steel ball, I'm showing that diagram here. When we are measuring diameter of steel ball, that diagram is shown here. So I'm giving you the readings here. Okay. So in these two diagrams, I am giving you the readings of the screw gauge, and there is nothing between the bolt and the stud, and when diameter of steel ball is measured. Pitch is given, least count is given. Give me the correct diameter. Give me the correct diameter. Give me the correct diameter of the steel ball. Give me the correct diameter of the steel ball. I hope that everything on the board is clear, visible, diagrams are properly visible. I will pronounce this is 38. This mark here is 38. This is written 10. Okay. I hope everything is clearly visible. Now give me the correct reading of the diameter of steel ball. You can start, because pitch and least count is everything is given. You can start by knowing the least, knowing the zero error and knowing the final reading. Okay, and observed reading minus zero error will be the correct reading. You can calculate the zero error first. Is it positive or negative? Zero error, is it positive or negative? 10th line is in alignment here. So 0 of the screw gauge should be below. After 0, 1, 2, 3, 4, 10th line is observed. So the 0 is below. 0 is below. So 0 error is positive. 0 is below. 0 is positive. Which mark is visible? 10 into least count. What was the least count given? Least count is 0.05 mm. 0.05 mm. 0.05 mm. So 10 into 0.05. You can multiply this. So 0.10 mm. This is the amount of zero error. And what is the observed diameter? 2 marks are visible. 2 marks are visible. What was the pitch? Pitch was 2 mm. So 2 into 2. This is the MSR, main scale reading. 2 marks are visible. 2 mm is least count. So mark visible into least count. This is the amount of main scale reading. Circular scale reading is 38 into pitch was 0.05. 0.05. 38 into 0.05. So now we can solve. Okay, you can solve this. So 2 to the 4 mm plus 38 into 0.05. What is 38 into 0.05? I think it's 1.90. Check, is this 1.90? 38 into 0.05. 38 into 0.05. Okay. So 4 plus 1.90, 5.90 mm. This is the observed reading, but there is also some zero error. So the correct diameter should be observed reading minus zero error. What kind of zero error is there? Positive. Put the zero error with sign always. So 5.90 minus 0.1, 5.80 mm. This is the correct answer. 5.80 mm. This is going to be correct answer. No, zero error. Acha, this is wrong. See, I am doing incorrect calculations here. This is wrong. 0.5 should come here. Na, 10 into. This is 0.5. By mistake, I am writing 0.1. 0.5. So correct reading should be, I should take 4 here. 5.40 mm. Yes. 0.50 mm. Okay. After subtracting this to 5.4 mm. 5.4 mm. Aditya, very good. By mistake, calculation I have done wrong. Okay. Is this clear now? Yes, Sumaraja. Very good. Yes, Sai. Okay, very good. So this is the idea of zero error. We have covered the zero error in screw gauge also. So what things we have covered today? We have covered the concept of screw gauge. What is screw gauge? What is least count? What is pitch? We have covered all these things. Okay. How to find the pitch? In one complete rotation, what is the distance traveled by screw? That is called pitch. In one complete rotation, the distance traveled by screw is called pitch. If there are 5 rotation and the distance traveled is, let's say, some x, so pitch will be number of rotations. You can divide distance moved by number of rotation. This is how pitch can be derived. Least count is the minimum length that screw gauge can measure. If there are n divisions on the cap, then least count is pitch by n. Least count of screw gauge is pitch by n. This is the ideal screw gauge with no zero error. In ideal screw gauge, when the bolt is touching the stud, in that situation, the zero of the cap, zero of the linear scale is barely visible, just visible, and the cap zero should be in alignment with the linear scale. This line is called linear scale, pitch scale, fixed scale. There are many names of this line, and this is called cap scale, circular scale, or head scale. Okay. In case of zero error, when the bolt is touching the stud, zero of the linear scale or zero of the cap scale is not in alignment with the linear scale. Either it is below or it is up. This is a case of zero error. The linear scale tells me the amount of complete rotation. In 3 complete rotation, the zero will again be in alignment of linear scale, and the gap here will be 3 pitch. 3 marks on the linear scale is visible. It means 3 rotations are completed. 2 or 1 mark is visible. It means 1 rotation is completed. After some extra rotation is done. So some other line on the cap scale, will be in alignment with the linear scale. What is the extra distance then? In each division, there is moment by least count. So in 36 division, there is moment of 36 into least count. This is the formula to obtain the length or diameter, whatever we are measuring by screw gauge. Okay, so today we have covered all the idea of screw gauge, and next class we are going to start concept of mechanical properties of solids. We are going to start mechanical property of solids. Okay, so I hope everything about screw gauge and vernier caliper is clear. Now you can solve all of the questions that you like. Okay, all the idea of screw gauge and vernier caliper is covered. Is this clear? And we will start with elasticity. So you can come prepared, you can read NCERT, elasticity from NCERT, that will help you. That will help you to understand better. Clear? Okay. So I will take your leave now. I have another class, another somewhere else. So bye bye everyone. Take care. Bye.